Imagine the universe as a gigantic, elastic balloon that's steadily being inflated. That's what dark energy seems to be doing, forcing galaxies further apart. Could this force lead to the end of the universe? Some scientists do think so, and they've named this potential event the Big Rip. It's challenging to study dark energy, even though it's one of the most fascinating aspects of our cosmos. That's because its only visible effect is this gentle stretching of space. On any smaller scale, it's virtually undetectable. Compared to dark energy, studying dark matter feels like a walk in the park. Even though it's just as invisible, dark matter leaves clear evidence of its existence. It latches onto galaxies and galaxy clusters, bending light and altering gravity. Dark energy, on the flip side, just expands. Nonetheless, scientists have found ways to examine it, mostly by observing the universe's expansion. As we peer into the distance, we are, in fact, peering back in time, tracing the universe's evolution. Dark energy could also bring about the end of the universe in a massive, catastrophic event. Imagine watching helplessly as reality itself tears apart with no hope of escape. Frighteningly, it's not some far-fetched scenario. The available data does not eliminate the possibility of a big rip. Is dark energy a force that keeps inflating the universe, or is it more like a separator? If two galaxies are far away from each other, they're driven further apart, leading to increasing cosmic isolation. But anything that's already a strong structure stays intact, immune to this divisive force. Why doesn't it mess things up, you ask? Well, it's because dark energy remains consistent. As space grows bigger, the density of dark energy remains steady. Imagine drawing a circle anywhere in space, taking note of the amount of dark energy there. Do it again after 1 billion years, and guess what? The amount of dark energy inside your circle won't change, even though space itself has expanded. That is, unless, of course, dark energy has a trick up its sleeve and proves to be more potent than a cosmological constant. All we know for sure is that it's something that drives the universe to expand more rapidly. Or to put it another way, it creates negative pressure. Now, negative pressure might sound odd. Pressure is usually seen as an outward force, right? But in the universe, it behaves differently. Pressure is a type of energy, like mass, that attracts rather than repels. All these calculations are what makes the Big Rip picture a slow, unraveling movie. The first objects affected are the most massive, loosely bound structures, like giant clusters of galaxies. Their gravitational pull will start weakening, causing them to drift away into the growing cosmic voids. Next, we'd notice stars on the outskirts of our galaxy not following their usual paths, but instead drifting away, like party guests saying their goodbyes. The night sky would then start to dim as our Milky Way would gradually evaporate. The disaster would just accelerate from there. The orbits of the planet would begin to shift, spiraling outward. Just months before the end, after we've lost the outer planets, Earth would drift away from the Sun and the Moon from Earth. We would plunge into the darkness alone. The stillness of solitude won't last, however. Any remaining structure would be destroyed because of the expanding space. The Earth's atmosphere would start to thin. Gravitational shifts would cause chaotic tectonic movements. In the final hours, Earth would fall apart. Beyond this point, the destruction would continue unseen. Nuclei, the ultra-dense cores within atoms, would disintegrate next. Black holes' dense cores would get obliterated. In the last instance, space itself would just rip apart. Bad as it may sound, we may never rule out the threat of a big rip. However, it might take so long that all cosmic structures will have decayed before it happens. A rough calculation suggests the earliest big rip could be in about 200 billion years. Technically, the Sun still has about 5 billion years before it fades away naturally. So by the time this event might happen, our solar system would have long been gone. Nonetheless, given the possible implications, scientists are placing a high priority on understanding the Big Rip. Let's be optimistic though. I mean, if we look at the universe's history, we should consider ourselves lucky. We're in what cosmologists refer to as the luminiferous era. It means that right now the universe is still pretty busy producing new stars, and we know how important these celestial bodies are for maintaining life as we know it. However, the golden age of star formation was about 10 billion years ago. Ever since that peak, the rate of creating new stars has been on the decline. Now, why is the universe taking this early retirement? It's not because it's lazy or tired. In fact, it's exactly because we're living in this expanding universe. For a new star to appear, a bunch of matter needs to be squeezed into a relatively small space. It's like trying to stuff all your clothes into a very, very small suitcase. As the universe expands, the matter is getting spread out, leading to less and less room in that suitcase for creating new stars. The Big Freeze, another theory related to the end of the universe, looks at this scenario. Stars will become endangered and then extinct species. This period of star decline is what astronomers like to call the degenerate era. It's estimated to start about 100 trillion years into the future. What'll be left in the night sky at that point? Only the hardened workers of the universe, white dwarfs, neutron stars, and black holes. White dwarfs and neutron stars, the remnants of medium and large stars that have exhausted their nuclear fuel, will eventually cool off and transform into black dwarfs. These black dwarfs are like invisible cosmic spirits, just hanging around without doing much, inert and unseen. Other neutron stars, too heavy for their own good, will stumble under their weight and collapse into black holes. Further into the future, the universe will become a black holes-only party. But even these cosmic weirdos can't cheat time forever. Black holes can fade away too. In fact, this idea of fading black holes came from a brilliant mind you might have heard of, Stephen Hawking. He suggested that black holes slowly shed energy in the form of radiation until they shrivel up like raisins and evaporate completely. Eventually, every single black hole will have evaporated. We'll be left with a universe in its twilight years, settling into its final age, aptly named the Dark Era. At this point, both light and matter will be nothing but distant memories. And then, well, nothing. If this Big Freeze theory is correct, the universe will just remain in a quiet, dark state, stretching into an eternity, where nothing else ever happens. Most of these theories seem to rely on the fact that the universe is expanding. But what exactly is it expanding into? We can't help but wonder if there's something else beyond our universe. Right now, this question is one for which physics doesn't quite have an answer for. We don't have enough facts. One suggestion is that time and space came to be with the Big Bang. That happened around 14 billion years ago, so logically there's nothing beyond the universe. However, a huge chunk of the universe is way out of our sight, existing beyond the part we can observe, which is about 90 billion light-years in diameter. Because everything's pretty much the same wherever you look in the universe, we can presume that the bits we can't see would look pretty much like the parts we can. But that's just an assumption. Now, if the universe is infinite, there's nothing beyond it, right? I mean, that's just what infinite means. On the other hand, if it's finite and growing, you'd start to wonder if there's a boundary or an edge, like a universal cliff that separates our universe from whatever is beyond it. It gets even more complicated when you realize the universe has at least 4 dimensions, 3 for space and 1 for time. And it's pretty much impossible for us to picture what that might look like.
What will the end of the universe be like? It might be 100 billion years away. But here's the real question. Should we start panicking already? Janna Levin, a cosmologist, appeared at a recent screening of the captivating Netflix documentary, A Trip to Infinity. She mentioned that there would be a time when the last sentient being exists and the last flicker of thought fades away. This perspective sheds a whole new light on things. Somewhere in the vast expanse of the universe, there will be a moment when the memories of legends like Einstein and Elvis will fade away. Just imagine what that last thought would be. A brilliant pearl of wisdom, a colorful expletive. The possibilities are as endless as the stars in the night sky. Now let's take a cosmic detour and explore how we got ourselves into this peculiar predicament. As we currently understand it, our universe burst into existence with a bang approximately 13.8 billion years ago. Since then, it has been expanding at an ever-increasing pace. For decades, astronomers debated whether this expansion would continue indefinitely, or if a big crunch awaited us in the distant future, where everything would collapse back together. Everything changed in 1998 when astronomers stumbled upon a discovery. The cosmic expansion was accelerating. This turbocharged expansion was fueled by a mysterious force called dark energy, woven into space-time's very fabric. The larger the universe grows, the more this enigmatic force pushes it apart. It's eerily similar to the cosmological constant, a concept introduced by Einstein to explain why the universe didn't collapse, only to be discarded later as a blunder. But guess what? The cosmological constant turned out to be a stubborn idea that refused to fade away. And now it poses a threat to both physics and the universe itself. If dark energy triumphs in the end, distant galaxies will eventually speed away from us so rapidly that we won't be able to see them anymore. With each passing moment, our understanding of the universe will diminish. Stars will extinguish and never ignite again. It will be akin to living inside an inverted black hole where matter, energy, and information are swallowed beyond the event horizon, lost forever. The star-making days of our universe are behind us. Star formation reached its peak nearly 10 billion years ago and has been gradually declining ever since. The reason for this waning of stellar light is our expanding universe. As the cosmos grows larger with each passing day, the matter within it remains constant but gets spread out over more and more volume. To create a star, matter must be compressed into relatively small volumes. As the universe ages, fewer opportunities arise for such compression. So, in the far future, we can estimate that the last star will be born approximately 1 trillion years from now. This final star is likely to be a small red dwarf, a fraction of the mass of our Sun. Red dwarf stars have extraordinarily long lives, slowly burning through hydrogen in a steady fusion reaction, but eventually, even they will exhaust their fuel. In roughly 100 trillion years, the last flicker of stellar light will fade away. This accelerated expansion will progressively limit our view of the wider universe. Although we can still observe distant galaxies because of the light they emitted long ago, their current light will never reach us. As the universe expands at an increasing rate, the boundary beyond which galaxies recede from our view moves closer and closer. One by one, galaxies will be torn away from us by the relentless cosmic expansion, accelerating so swiftly that their light will forever elude us. Anything not gravitationally bound to us will be unable to withstand this onslaught. Only the local group, consisting of the Milky Way, Andromeda, Triangulum galaxies, and several satellite dwarf galaxies, will remain in our proximity. However, this lingering existence will be far from idyllic. Over time, our 3 galaxies will merge into one mega-galaxy, completely isolated from everything else in the universe. In this solitary state, the mega-galaxy will slowly dissolve. Chance interactions will scatter individual stars, or what remains of them, into random orbits. Some will be hurled into the giant black hole at the center of the galaxy, while others will escape into the void, never to be seen again. After an unimaginable span, no complex systems will endure. All that will be left are isolated islands drifting in an infinite expanse of darkness. To make matters worse, as thinking requires energy, there will eventually come a time when the universe lacks the energy to sustain a single thought. Eventually, all that will remain are subatomic particles, dancing in the vast expanse of intergalactic space, engulfed by eternal darkness. This will occur trillions upon trillions of years after the last glimmers of light and life have vanished. And then, countless eons will stretch onward to the point where even measuring the passage of time becomes impossible. As Brian Greene described it in his book, Until the End of Time, it's a tale full of sound and fury, signifying nothing. This might make us feel some sort of weight of insignificance in the face of this cosmic destiny, If this truly is the fate awaiting the universe, it's both humbling and disheartening. Our universe may be 14 billion years old, but that's just a fleeting moment compared to the unfathomable darkness that lies ahead. It means that everything remarkable in our universe occurred in a mere blink at the beginning, followed by an eternity of emptiness, its finality and futility on an unimaginable scale. But hold on a second. Before we surrender to despair, let's remember that we're still a long way from this inevitable end. New discoveries in physics could provide a glimmer of hope, an escape hatch from this fate. Perhaps dark energy is not constant. Maybe it will change its course and bring the universe back together. Michael Turner, the brilliant cosmologist who coined the term dark energy, emphasized that the cosmological constant would be the least interesting answer to the dark energy puzzle. So, who knows what surprises the future holds? But for now, we can't help but peer into the abyss and wonder. We are but brief inhabitants of this cosmic spectacle, here for the grand party when the universe brims with life and light. We may not have a say in the final act, but we can cherish the here and now, reveling in the magic of the present. As astrophysicist and philosopher John Archibald Wheeler once said, the past and the future are mere fictions, existing only in the artifacts and imaginations of the present. From that perspective, the universe ends with each of us, granting us a unique perspective and a chance to make our mark. So let's embrace the fleeting nature of existence. Though the future may be finite, it liberates us to fully appreciate the wonders of this moment. After all, as the saying goes, nothing lasts forever, whether it's the stock market, the stars, or even our own lives. An awareness of eternity's whiff can illuminate the brilliance of a lifetime, even if it's just mine or yours. There is more than one theory about how the universe is going to be gone forever. In the world of quantum field theory, for example, we come across something called a vacuum decay. Picture it as a vacuum that's kind of stable, but not totally rock-solid stable. This false vacuum can hang around for quite a while, chilling in its semi-stable state. Could eventually say, nah, I'm done, and transform into a more stable vacuum. We call this wild event false vacuum decay. It's like a cosmic game of Jenga, where the unstable blocks finally collapse, and the universe finds its true balance. So, cosmic adventurers, let's treasure the Milky Way and all its splendor for as long as it lasts. And who knows, maybe in the vastness of this ever-expanding universe, there's still a surprise or two waiting for us. The story isn't over yet, and the cosmos is filled with secrets waiting to be uncovered. What do you think the end of the universe looks like for us humans? Are we even going to be around to witness it?
Have you ever wondered how the world will go down in flames? Will it be due to zombies, extraterrestrial civilizations, or AI taking over? Nah, turns out it might actually be mosquitoes and scientists causing the chaos. It's funny how things created by nature aren't as threatening as the stuff that doesn't exist naturally. And you know what's on that list? Editing the DNA genome. Experiments with the genetic structure of living organisms can produce completely new species, and no one knows how nature will react to them. Let's look at an example of gene drive. So it all started with malaria mosquitoes. To somehow stop the growth of their population and prevent the spread of malaria, scientists created a gene that magically made mosquitoes only have male offspring. Several insects with this gene transmitted it to others during the mating season, and thus spread infertility. Scientists were able to stop malaria and destroy almost the entire mosquito population. But imagine if something went wrong in the mosquito genome and their population began to increase exponentially. Malaria could spread across all continents and create huge problems for all of us. Now, let's move from the little mosquito problem to a planetary disaster that can be caused by the desire for knowledge, which is deeply embedded in our nature. British cosmologist Martin Rees once said that we lived in the 1st century when human beings could determine the planet's future. It seems that it's so easy not to destroy yourself, but our nature is quite complicated. In pursuit of solving the mysteries of the universe, we have built a giant machine that, according to some people, may destroy our planet. And this device is the Large Hadron Collider. The main task of this giant machine is to accelerate particles and make them collide with one another. Scientists expect that the collider will help better understand the structure of our universe. In simple words, this is a miniature simulator of the universe. Using it may also shed light on the mystery of dark matter. During operation, the machine compresses atoms and makes them crash into one another at great speed. Perhaps this is how our universe appeared. Some people fear that a small black hole may form because of this collision. A tiny particle with a huge weight will pull all objects inside itself. Its mass will grow, but its size won't change much. As a result, it will compress the entire Earth and turn it into a ball measuring a little more than 300 feet across. At the same time, our planet will still have the same weight. A powerful gravitational pull on such a small area of matter can form a black hole that might later swallow up our entire solar system. There are also theories that the Hadron Collider could open a portal to a parallel universe with creepy monsters that would enter our world. But of course, such theories have little to do with science. Scientists have already launched the collider several times, and as you can see, nothing terrible has happened. But there is a small nuance. With each launch, scientists increase the speed of particles. Who knows what will happen when they accelerate them too much? According to Martin Rees, the probability that Earth will become a black hole is very, very small. Particles with a much larger energy charge fly in space faster than in the Hadron Collider, and nothing catastrophic happens. Okay, now let's go back to our genomic games to see what else can happen if we continue experimenting with nature. The main problem might be an imbalance in ecosystems. In the 19th century, sailors accidentally brought mice to Gough Island in the South Atlantic Ocean. Rodents had no dangerous enemies there, so their population began to grow. Mice began to displace dozens of birds from their home. The rodents attacked the chicks and reduced the population of entire species. Trying to save the birds, scientists decided to get rid of the mice, but these little creatures still managed to survive. As a result, the balance of the whole ecosystem was disrupted. Using gene drive to get rid of one species can lead to uncontrolled population growth of another. Imagine that malaria mosquitoes controlled the population of some flies. And what would happen if these flies lost their main natural enemy? The population of these flies would start destroying other species, and it would begin a chain of destructive events. All this suggests that playing with things that don't exist in nature is very dangerous. We worry a lot about how artificial intelligence can take over the world and eliminate us. Still, at the same time, we don't pay attention to our actions. Genome editing can lead to positive consequences, such as the appearance of healthier people, and destructive ones, like the creation of artificial bacteria that can cause serious health problems. In general, destroying other species is a trait inherent in humans. Because of our actions, many animals have disappeared from the face of the earth. Moreover, we even destroy each other. Such aggressive behavior is our nature. And artificial intelligence doesn't have anthropomorphic properties. Its logic may be completely different from ours, and instead of destroying people, it might strive to save them. And we have something to save us from. Remember the giant asteroid that erased more than half of the living creatures on Earth? The fall of the space rock caused a massive blast wave, a tsunami, earthquakes, and dust clouds that covered the sun. Dinosaurs and other animals couldn't survive in such conditions. But what if something similar happens these days? Fortunately, we're better prepared than dinosaurs. Firstly, we have the technology to track giant meteorites and calculate their trajectory. And artificial intelligence can also help us with this. Secondly, we can destroy an asteroid before it reaches us. Several powerful rockets will quickly deal with any space rock and turn it into cosmic dust. Moreover, we will know in advance about its approach. But suppose that a huge stone the size of dozens of Everests will fly towards us. In that case, humanity should hurry with Mars colonization. But don't worry, Observing the sky shows that large asteroids capable of causing severe damage to our planet are moving in a different direction. The most giant known asteroid that could collide with Earth might do so in 2088. The probability that it will fall on our planet is 1 in 50,000, so you shouldn't have to worry about threats from outer space. What lies in the bowels of our planet is much more dangerous. Millions of tons of magma and hot gases can burst to the surface through destructive volcanic eruptions. More than 70,000 years ago, a large-scale eruption threw a tremendous amount of ash into the air, which then floated in the atmosphere in the form of a giant gray cloud for a long time. As a result, Earth's surface cooled down by several degrees, which led to one of the most massive extinctions in the history of our planet. Some eruptions happen not only inside volcanoes. There's such a thing as flood basalt. A colossal magma bubble accumulates under a vast area and begins to seep through faults in different parts. Magma slowly goes out there for many years and destroys all living things around. And the worst thing about this situation is that we can't do anything about it. Humanity has learned to track meteorites in space, but we're still not good at predicting a volcano's behavior. Even if we find out that some giant rock will wake up in the next 6 months, there's nothing we can do about that. We won't be able to prevent an eruption. All we can do is evacuate people from dangerous territory. We have no protection against earthquakes, and even more so, we can't stop the emission of ash into the atmosphere. It's possible that artificial intelligence will help us with this in the future, but right now, we're powerless. As you can see, there are several options for the end of the world for humanity, and they're all slightly different from those imposed by pop culture and the media. In the end, is it right to look for threats from space or artificial intelligence?